Good morning, everybody. My name is Shubha Rao. I'm a product manager in Amazon Web Services, and I'm here to speak about App Mesh. So the agenda for today is going to be that I will give a quick introduction of what App Mesh is, what its capabilities are, and what's coming soon. And then we will have two demos today, one with App Mesh with ECS and the second one App Mesh with EKS. So I want to start with a quick overview into why we built App Mesh and what high-level capabilities it provides before you really see a demo of it in action. So many of our customers are modernizing applications to become more agile and to innovate faster. And architectural patterns like microservices help customers create a culture of innovation in their organizations. It helps developers build independent services somewhat in parallel and to deploy their changes without having to wait for the other teams and to coordinate with other teams. This approach optimizes for productivity and allows teams to experiment and iterate faster. So overall, it helps companies scale and run their applications in a much faster, agile manner than previously. But the few things that are totally required for this pattern to work is to get a sense of control and visibility into how these services communicate with each other and how they all come together to do the business logic that they are intended to execute. And all that has to happen in a manner where your applications are running with utmost security and compliance. To build these type of frameworks which enable teams to innovate fast is something that all our customers are thinking about. And a few components are needed to really enable that. So if you think about how it's done today, there are people and there are systems which are built to interact with each other, and the communication is almost manual in a lot of places. So as you build new services and as the number of these services scale, to work together, you need new ways to connect, to monitor, to control, and to debug the communication. And all this, the more automated it is, the better it would be to make sure that there is fast progress in terms of app development. So if you think about systems architecture, this is the OODA loop, the observe, orient, decide, and act. So where observe is getting visibility into the systems, into the services that are a part of your application. Orient is to understand where the failures are or where the inconsistencies are. And decide is how for you to decide what type of controls you want to put into the services that are part of your app. And act is getting a consistent application experience, in the sense getting consistent controls to control how your services interact. So overall, what these capabilities translate to in a microservice architecture or even in terms of application components is that you would need service discovery to identify which services are running where and how they work together. You need visibility in terms of app-level metrics and logs, not just infrastructure-level metrics and logs. You need traces to understand the actual path and to help you debug the traffic patterns. You need traffic shaping, and you need the ability to secure all this communication between services. Today, you have to build a lot of this logic either into your application, or many customers of ours model it into as their SDKs that they run with their application code. But as the number of your services increase, as the number of your teams increase, that process becomes harder and harder to manage, because getting consistency in terms of the capabilities, the language library versions, the security patches needed becomes really complex. So our goal is to help you get uniformity in managing inter-service communication. And the approach is that we want to give you declarative APIs where you just tell us what capabilities you need, and we will program it as a part of the infrastructure so that you just don't have to worry about keeping track of all the libraries and their versions. So the common capabilities which are important to manage communication is what's called observability. That's the logging, metrics, and traces. There are also capabilities to help shape traffic patterns, be it client-side load balancing or be it blue-green or canary deployments. And there's also encryption that needs to happen for many of these services. And you want to do it in such a way that you're not really having your service team think about all this overhead. You want it to be somewhat independent and decoupled from the service team so that you're minimizing the impact to application code. So what does App Mesh do and how does it work? So in App Mesh, we use a proxy with a managed control plane. So the proxy manages the traffic between services, and it can observe all the traffic that is going between the services that are a part of the mesh. So you express your intent through the App Mesh API and the App Mesh constructs, and the control plane, that's the App Mesh, translates that into what configuration is needed at each of these proxies and distributes it to the proxies. So the benefit of this overall system is that you're decoupling the logic that manages the communication between services and making it a separate part of your application deployment. And you're programming it at the proxy that runs along with your application, but not as a part of your application. So this also makes the proxy be very separately configurable, and it separates the business logic from the operational logic that is needed for your app communication. This also gives you programmability, and it minimizes the inconsistencies in how different services interact with the traffic. So if you want to get detailed insights into metrics that are going on, metrics about the communication path, then you can totally easily program it at the proxies across multiple services without having to work with each of the independent teams to use the same right settings at each of their independent application code. So overall, App Mesh is focused on delivering a highly scalable, resilient mesh, where the mesh is made of these proxies that are sitting with your applications and managing the application communication. The App Mesh control plane, which is an independent part of your mesh, is just programming the mesh, and the mesh itself is a set of proxies that work with each other and provide additional capabilities for the services that they're running with. So how did we think about App Mesh when we built it? We wanted to actually have it serve a set of specific requirements which we heard from our customers, which includes the ability to bring the mesh to services that are running on any type of compute platform. And I'll speak a little more about it in the coming slide. We also wanted to remove as much heavy lifting as possible from configuring and running the service mesh. And that means we did not want you to be in charge of setting up and scaling and patching the components that are programming the proxies. We wanted to take that away from you, and so we built App Mesh to be an Amazon-managed control plane that you can just use with your services wherever the services are running. So App Mesh brings you integrations not just with Amazon services, and it also works with any type of service that is integrated with the proxy itself. The proxy choice we made here is Envoy. Envoy is a CNCF project which is now used by several customers of ours. It sits with your application in the sense that you package it as either as a part of the ECS task definition if you're using ECS, or part of the EKS pod, or you can inject this sidecar transparently into your application service pods. If you're using EC2, you can either deploy it on EC2 directly or as a container. And the envoys that you deploy along with your service code is programmed. They connect to the App Mesh control plane that we manage, and they get the right configuration that is needed for those services. How do you think about what exactly you want to configure at App Mesh? So the model that we use is that each service is owned by an independent service team, and the service team manages what config needs to be applied to the clients that are communicating with that service. So on the example here, if you are service team B, the way we think about the policies that goes to the mesh is that you program the policy that is needed at the mesh for service B. Essentially, you say, all clients that are connecting to my service B need to use this type of a policy. They need to send X% traffic to my new version. They need to retry, Y number of times and things like that. And App Mesh identifies what endpoints belong to the clients that are communicating with B and programs the envoys that are deployed with the endpoints that are on the client side. And the App Mesh APIs are designed to provide these type of boundaries and to respect these type of boundaries. So whether you're a small team that owns the mesh for all the services or whether you're a large enterprise where each service owns its own mesh config, you should be able to model that with App Mesh, and App Mesh enables safe transactional changes to all the components on the data plane. You may need the flexibility to even migrate services across these platforms. And App Mesh allows you to not just run services and provide you connectivity management for these. It also enables you to build a migration path and manage the communication paths between these services. So when I speak about mesh capabilities, what all do I really mean? At a high level, the App Mesh and Service Mesh constructs provide deeper observability. And by observability, it includes logging, it includes metrics and tracing. So as of now, we have worked with CloudWatch, and we have worked with a whole set of partners that you see here to bring in logs and metrics into these solutions. So we also have integrations with X-Ray. You can also bring in tracing integrations that work with Envoy. On the traffic management side, the capabilities that we have today is path-based routing for TCP and HTTP. You can do client-side load balancing. App Mesh handles service discovery and be it DNS or be it using our new service AWS Cloud Map, which provides you HTTP API-based metadata-based service discovery. Envoys do health check, and we program it to make sure that only the healthy service endpoints are returned to in any of these communication. We're working on the retries, timeouts, and circuit breakers, which are essentially called traffic shaping policies. We have some proposals out on our open source GitHub, and we will be launching these capabilities soon. On the routing side, we already support HTTP and TCP. We'll be soon supporting gRPC. Today, you can do path-based routing. Soon, you'll be able to do header and cookie and based routing as well. So a lot of our roadmap is public. You can go on GitHub App Mesh roadmap and get a sense of what exactly we are working on. You can give your inputs on the type of features that you want us to develop and the things that are working well and not working well for you. So we want to quickly jump into a couple of demos on how to use App Mesh. And before that, I want to introduce a few concepts. The main big concepts that App Mesh introduces is the mesh itself, which is the entire communication boundary of your app communication. There are virtual nodes which represent versions of a service that can interact with each other. There is virtual router and routes which help you model what exact communication is required between your services. So note that in our implementation of the mesh, all services do not connect to any other by default. You have to explicitly model the communication paths for the services to be interacting with each other. And then there's a virtual service, which is a representation of your actual service along with its DNS name and other things. So what's running behind the scenes to help you model all these constructs is a set of proxies that you deploy along with your services There is service discovery, which has a service name and a set of endpoints. And for this, we are using AWS Route 53 and Cloud Map. The application that you're going to see in a lot of our demos today is called Color Teller. It's a very simple app just to demo the capabilities that you can use with App Mesh. Very high level, it has a ALB as a front end. There is a gateway container in the sense it's not a real gateway in the sense of an API gateway, but it's a task that is a front end task that is the ingress point for the app. And then there is a color teller task, which is something like a backend. And in this specific case, it just returns a color. So you can make a request from the external world, the gateway routes that request to a color teller task, which picks a color. And there are multiple copies of the color teller task that we deploy, each on different, it could all be on the same service or multiple different services, compute services. You'll be just using App Mesh APIs to model this and see a few of our capabilities. And with this, I want to transfer it over to Tony, who's going to give you a demo of this app running in ECS.
Thanks, Shubha. Okay, so I'm going to use a very simple application to demo shifting traffic according to some weighted percentages. This is the application that Shubha just mentioned. We have the application published on our repo. You can go to this repo up here on github.com, and it's under examples, apps, color app. So I've already deployed this application. You can, and after you deploy it, you'll be able to take a look at your deployed stacks running here. Log into your console, take a look at your CloudFormation stacks. You can see that we partitioned this into a few layers to make it make more sense logically, and as far as redeploying the application when you make changes, a little bit easier to do that. So you can see that we deployed our VPC, we deployed App Mesh itself, we deployed an ECS cluster, the compute resources to run our application. We've deployed the actual mesh resources for this specific color app, so that will be our virtual services, our virtual nodes, virtual routers, our routes, that kind of stuff. And then we've deployed the app. And along with that app, we've attached a public load balancer. So I've got an ALB here at this address right there. And we'll use that so that we can actually ping the service. Here you can see that I've got a number of EC2 instances that was a part of our deployment. And then we can also see that the mesh itself was configured. It's been deployed and available from the AWS App Mesh console itself. You can actually come in here and create your own meshes or make modifications to the existing mesh. We chose to use CloudFormation to make this deployment repeatable. So I've already pinged. I've set it up right now so that I am only returning one color every time I ping the color app route. We have this front end to the application, this gateway service that is reaching out to a color teller to fetch a color. And the current color is being routed by App Mesh to our color teller blue virtual node. And that is the response that I'm seeing here. I'm getting back a blue. I can come into our AWS X-Ray console and I can actually see what's happening with this traffic here. I've got a request that came in, and the first thing that the request does is it hits the Envoy proxy that is a sidecar to our gateway task running as an ECS service. So this request came into Envoy, which intercepted the ingress traffic to default to our gateway. And then gateway makes a GET request to a color teller. This request comes back out through Envoy, which has been configured by App Mesh to forward this over to color teller blue. Because according to our rules right now, 100% of our traffic goes to color teller blue. Color teller blue, of course, has its own sidecar, a proxy that intercepts the traffic and then passes it on to the actual service that's going to return the response. And so we saw blue. So let's take a look at making a change to this configuration. So here's a configuration inside of the AWS App Mesh console. I'll go into virtual routers. I'll drill into our color virtual router. So now that I'm at this screen, I'm going to drill into the actual route to make an edit. Okay, so now that we're at the virtual router, our color virtual router, we're going to click on this route. Right now, it's configured to send all of our traffic to the color blue virtual node. So that's 100% traffic. We're going to make a change here. What I'm going to do is I'm going to add another target, and I am going to choose, for this example, color red. And just to make the number simple, let's make this a 1-to-1 shift. Okay, so you can use any integer value so long as they add up to 100. So I can use 50-50, 1-to-1, or even whatever that gives me a 100% shift on the traffic. And I'm going to save that. So when I take a look here, I can see that 50% of my traffic will go to blue, 50% will go to red. Let's start making some requests here. Okay, so I just got back a red response. And since this stats here represents a histogram, over time, if I do this enough, I'll see this starting to approach 50-50. Right now, it's mostly blue responses. We just started getting red, so I'll just keep refreshing. And you can see roughly a 50-50 distribution between red and blue. That's how fast that happened. And if we come to our AWS X-ray console, I should be able to refresh this. And click refresh. Give it a minute to catch up. By the way, let me make a note here. Let me point out that when you first come to your X-ray console, you may see a lot more information than you expect to see. So right now, my app is the map is updating. You may see other clients and a lot of traffic you don't expect to see, and that's because we've got health checks enabled for the app. So what I did is I configured a group to filter traffic, and that traffic is filtered on just the traffic we're interested in coming through the gateway on the routes that end with color instead of any of the health check routes or other routes. Now let me choose this. And it's updating, and I should see, and there we go. It's updated, and I can see the traffic has come in through the gateway proxy sidecar, and then out to ultimately to our two different color tellers, color blue, color red, giving us roughly 50% traffic distribution. So I want to mention that this walkthrough that I'm doing, this type of weighted traffic is useful for a number of different deployment scenarios. So you might use this for different types of deployment patterns like blue-green deployments, A/B testing, canary tests, that kind of stuff. And there's more information available at the repo and associated README material available online that drills into this and provides more background on what's actually happening under the scenes. I can do this at the command line, what's going on with the different configuration files, that kind of stuff. Finally, I do want to mention also that the X-ray instrumentation provides you with this very nice map that allows you to analyze how your application is doing, the latencies that's going on. You do have to do a little bit of work to instrument your app to provide that context for those X-ray routes that you see here. Now, we also have CloudWatch logs and metrics enabled, and you're going to get CloudWatch logs based on your Envoy proxies out of the box. And since all traffic flows through those proxies, it gives you really nice insight into all the requests that are flowing through the application and your requests, your responses, if you're trying to debug and look at it that way. So if you click into the log group associated with Color App, you'll see there's a lot of information in here. We can drill into different, specifically like color red. Let's take a look at the last one that we had just used. And I can see all the requests coming in to color red. So I've got logs. We get all of this without doing any work in our application. It's just printing the standard out. But all this traffic flows through Envoy, so we're able to capture it at the Envoy level and make sure that they're here in the logs. So again, you can take a look at this color app demo. It's up online on GitHub under AWS/AWS-App-Mesh.examples. Thank you very much. I'm going to go ahead and hand off now to Michael Hausenblas.
Let's now continue with App Mesh on EKS. For that, I've put together a little walkthrough. Provision the cluster with EKS control. That's the command I used here, EKS control. Create cluster, giving a name, using two nodes there. And most importantly, here with that flag, App Mesh access, the EKS cluster provisioned has the correct permission set to create the App Mesh resources. That might take a few minutes, so I've prepared that already, and set kubectl to actually point to that cluster. So I'm here now using Cloud9 to show you that, and let's have a look. Kubectl version short, and you see that on the client side I have 1.14 version, and I'm connected to a 1.12 cluster here. All right. Okay, so the first thing we're going to do is create a component that is called App Mesh Inject, and that essentially, if you look at it, is responsible for injecting Envoy as the data plane, as a sidecar to each of the app pods running. So by simply setting a few environment variables, I need to tell which named color mesh should be. That's done with this environment variable. And then I need to configure that I actually want to also enable the sidecar injection for X-ray, because later on we're going to have a look at the traces there as well. All right, and two more here. Copy, paste, configuring the respective settings here. Once that is done, a simple curl command goes off and installs the inject. Once that is done, let's have a look at the namespace. Currently is just the default public and system there, and once that is done, once we've installed the inject, of course I've forgotten to install JQ before that. Gonna cut that out, and once that is done, we should see a namespace called inject, very aptly called, and in that namespace we expect a pod running. So let's see, kubectl get namespaces. We now see the App Mesh inject namespace, and if we peek in there, kubectl minus namespace App Mesh inject. Let's just list all for that. Yeah, I get would certainly help. Then we see the pod running, service running, deployment running. All is good. So we are set. All right. Next, we install the App Mesh controller. The controller is actually taking care of the entire lifecycle, creating the underlying App Mesh resources, the App Mesh, the mesh itself, virtual nodes, routes, and so on and so forth for us. Right. So I'm going to install that. Pretty straightforward. And once that is done, we should see another namespace, kubectl get namespace and that is called App Mesh system. And within that, you would expect the controller running. So you can check that if everything is up and running. That should be fine. Just take a few moments to pull the image, and it is running. Perfect. So now we are all set up everything. We are ready to actually deploy our application. Before we do that, we have a quick look at what is actually available in the system right now, and that is the custom resources that we've installed, and that is the mesh itself, which is cluster-wide resources you can see here, and the virtual nodes and virtual services, which are looked after by the controller, which is installed in the previous step. All right, so we're all set, and I'm going to use the Color App application to actually demonstrate that. So let's clone that repo here. And once we have that locally, we change into that repo here and actually make example, which essentially deploys the resources for us. All right, so that is done. And with that, we now have a look at all the resources that have been created in this new namespace App Mesh demo. Then we should see, all of that should be running by now. Maybe pods are still pulling. No, it's already done. So that's pretty quick. So let's have a closer look at the things that are there. Obviously, as one would expect, we have the deployments for the color gateway, color teller. If you're not familiar with the color app itself, have a look at what the components are. I'm not going to go into great detail here. I'm just looking at that from the perspective of the setup on EKS. Here, more importantly, you see 3, which means there are 3 containers running in each of those pods. The main application container, the Envoy proxy that has been injected by the inject component, because we've labeled that namespace as enable App Mesh in this namespace. And the third one is the X-Ray sidecar. If you remember early on when we set up the environment variables, what we said, we actually want to enable this so that we then can have a look at it through X-Ray. So we can have a look at the traces and so on and so forth. So all looks good, all is up and running. And actually, you see here, down here, the custom resource virtual node and virtual service. Which means if I now go to the App Mesh console, I should see the color mesh there. Very well done. And if I drill down here, I see the respective services, routes, and nodes. So I didn't have to do anything other than enabling it, and the controller and the inject would do the magic and create all of that for me. So now we can actually use the mesh. A couple of AWS App Mesh commands where you can essentially do the same that we just did in the console and the command line. But the first thing, just try out if the app itself is actually working, is to go here and launch this curl pod that essentially allows me to jump into the cluster. Think of it like a jump best in host. And once we're in there, we can curl this color gateway service right away. So we're now inside the cluster, and we should be able to get back this color here, right? Can do that color gateway, forwarding it, picking one of the color tellers here. Perfect. All right. So that works. That's great. And now we are actually ready. We can now go on to other things with that. You can have a look at CloudWatch, or what I will be doing now, having a look at X-Ray, because I find that pretty essential for any kind of containerized microservices development, to actually have a look at what is going on there. So what we have to do there is to actually give the respective permissions, so we need to go through that. Everything else is done for us. Everything else has been configured, so we only need to grant permissions, and then we should be good and have a look at our little application in X-Ray. And this one. And finally, we're gonna attach that so that we can actually get the traces back there. All right, and now let's minus namespace. Let's have a look at the namespaces again. So we're using the App Mesh demo namespace here. So kubectl minus namespace App Mesh demo. Just have a look at the parts. And here we see the curl is still running, so we're going to reattach to that one. And that we do with exec minus it, then this part here. Oops. We need this part here. And we should also specify, let's just say bash. All right. So let's do some more invocations so that we have some data for X-Ray to look at. Right, so we're gonna do some more curls against that service, against the gateway service, and then just a few, doesn't really matter. Okay, now we're ready to actually look at X-Ray. And by now we should actually have some traces here. As you can see, color gateway, and we can actually drill down and have a look at the invocation here from the gateway to the respective teller. And this is a super powerful integration that essentially was just enabled by a single environment variable where we said inject this X-Ray agent sidecar. Same you can do for CloudWatch. And with that, we're going to wrap up. I hope you enjoyed that and learned a little bit about how to use App Mesh with and on EKS.